Hey guys, thank you very much for watching my tutorials. You can even subscribe to my YouTube channel, or you can email me at nsubugaexplains@gmail.com. Today, we want to look at this term aromaticity. This word aromaticity comes from the word aromatic. Previously, aromatic compounds they were described as those compounds which are having a pleasant smell. However, aromaticity, we talk about aromaticity of recent, we are referring to planar cyclic structures with alternating double bonds, which gives it an increased stability. Looking at the most common aromatic compound that we have, benzene, looking at the benzene ring, benzene ring has 3 pi bonds, but these pi bonds are not fixed in one position. They keep on moving within the entire ring. So a benzene ring has alternating double and single bonds. That's why you can come up with something like this. So normally write a benzene ring in this format with a ring of delocalized electrons. So our focus is to look at what are some of the conditions, because benzene is not the only compound which is aromatic. We have quite a number of aromatic compounds which are aromatic, but we want to look at what are the conditions a compound must satisfy in order for it to be considered as aromatic. So our first condition for that we're going to look at is a compound must be cyclic. What do we mean by being cyclic? Being cyclic means that the first carbon must be connected directly to the last carbon. Using our common example of a benzene ring, our first carbon is directly attached to carbon number 6. So such a compound is considered to be cyclic. So one of the conditions is cyclic. Now, going back here, looking at our compound here, this compound here, looking at our first carbon, it is not directly attached to carbon number 6. Therefore, this compound is not cyclic. It is just a linear compound. It's an aliphatic compound. Actually, we can write it in this format, or we can write it like this, because our first carbon is not connected to the last carbon. And when you write it in this format, this is going to be called 1, 3. We say the first condition was cyclic. Cyclic, and we will say that the first carbon here is not directly attached to the last carbon. Therefore, this compound is not cyclic, but it is linear, or it is aliphatic, which you can write it like this, and it is 135 hexatri N. Then our second condition is being planar. All the carbon atoms must be planar. All the carbon atoms must be planar. Planar means flat. All the carbons must be sp2 hybridized. They must be in this format here. So looking at our simple, most common organic compound, which is aromatic, which is a benzene ring, all the carbons in this molecule here are in this format. They are sp2 hybridized. They are trigonal planar. We don't have any carbon which is sp3. All of them are trigonal planar. Therefore, such a molecule is considered to be planar. Then our third condition is being conjugated. Conjugated or resonance. Still looking at our benzene ring, this bond can alternate and move to this position. This one can move to this position. This can also alternate and go to this position. So you find that the benzene ring has alternating single and double bonds. When these bonds alternate, we shall come up with a structure like this one here. Or we can write our benzene ring like this, with a ring of localized electrons. Looking at this compound down here, these two carbons are sp3 hybridized. They are sp3 hybridized. Therefore, no resonance can take place at these carbon atoms here, because they already have 4 bonds. Looking at our sp3 is like this. If it is sp3, the bonds, it is surrounded by 4 bonds, already full. So no resonance can be accepted by this kind of arrangement of a carbon atom. That's why this compound here cannot undergo resonance, or is not conjugated. Then our last condition a compound must satisfy in order to be considered aromatic is it must be obey Parker's rule. Parker's rule of 4n plus 2 is equal to pi electrons. N is an integer. When n is a whole number, that compound is considered to be aromatic. If it is a fraction, it is anti-aromatic. Still, putting our focus on the most common aromatic compound, which is a benzene, it has 6 pi electrons. Three of these bonds, three of these localized bonds or pi bonds, each one having 2 electrons, so totaling to 6 electrons. So 4n plus 2 is equal to 6. Your n is equal to 1, which is a whole number. Therefore, it obeys Parker's rule. So this compound is considered to be aromatic. Then our compound down here, it is cyclic, it is planar, it is conjugated. Then 4n plus 2 is equal to 4. It has 4 pi electrons. So our n is equal to a half. A half is a fraction. Therefore, this compound here is not aromatic. It is anti-aromatic because it does not obey Parker's rule. So those are the 4 sets of conditions a compound must satisfy in order to be considered aromatic. We said the first condition was cyclic, planar, conjugated, and eventually it must be able to obey Parker's rule. Thank you very much for watching my tutorials. You can subscribe to my YouTube channel, or you can email me at nsubugaexplains@gmail.com. Thank you.